Good morning. It's November 13th, and this is your daily brief in science. Here's everything you need to know. New research from Case Western Reserve University has emerged, challenging long-held beliefs about how galaxies formed in the early universe. Published on November 12, 2024 in the Astrophysical Journal, this study led by astrophysicist Stacy McGaugh proposes a radical shift in our understanding by suggesting an alternative gravitational theory known as modified Newtonian dynamics, or MOND. This theory posits that galaxies could form rapidly without relying on dark matter, a concept that has dominated astrophysics for decades. The research draws on data from the James Webb Space Telescope, which has uncovered unexpectedly large and bright galaxies existing much earlier than previously theorized, shortly after the Big Bang. Contrary to expectations that the James Webb Space Telescope would find many small galaxy precursors, it instead detected these larger structures at higher redshifts, prompting a re-evaluation of existing theoretical frameworks. These findings align with MOND's predictions made over 25 years ago regarding the early emergence of massive galaxies and clusters. McGaugh stated, "The bottom line is, I told you so," emphasizing the validation of MOND over dark matter theories. This research directly challenges the widely accepted hierarchical evolution of galaxies, driven by cold dark matter, which has been used to explain the diversity in galaxy shapes and sizes. However, the acceptance of this research within the scientific community remains uncertain, as past claims that contradict major physical theories have often faced skepticism. Additionally, integrating MOND with general relativity continues to pose challenges, as noted by co-authors Federico Lelli, J. Frank, and James Schaumbert. If confirmed, McGaugh's team's hypotheses could significantly impact the field of physics, possibly revealing deeper truths about the universe's composition. Complicating matters further, some of the bright sources detected by James Webb Space Telescope may actually be supermassive black holes rather than galaxies, adding another layer of complexity to the interpretation of early cosmic structures. Recent research has uncovered sandstone formations known as tava, located near Pikes Peak in Colorado. These formations are believed to have formed from solidified sand injectites, created under immense pressure from an ice sheet combined with meltwater. About 700 million years ago, Earth experienced a significant cooling event known as Snowball Earth, characterized by ice sheets encasing the planet for tens of millions of years. This study provides the first physical evidence supporting the Snowball Earth hypothesis, indicating that ice sheets reached warm equatorial regions, which previously lacked direct proof. Understanding the climatic conditions during this period is vital for scientists as it relates to major evolutionary milestones, including the emergence of multicellular life. The findings were published in the journal Proceedings of the National Academy of Sciences on November 11, 2024, marking a significant contribution to the understanding of ancient climate events. The research links the Tava rocks to the cryogenian Snowball Earth period, resolving long-standing debates about their geological origins. Researchers suggest that the immense pressure from the ice sheet caused meltwater mixed with sediment to be forced into the weakened bedrock, a process reminiscent of modern fracking techniques. The Tava injectites are believed to have formed near the equator on the ancient supercontinent Laurentia, which has since drifted to its current location in North America. The unusual pebbly sandstone at Pikes Peak is now recognized as a crucial piece of evidence linking to the Snowball Earth theory, emphasizing the area's geological significance. Despite the extreme conditions of the Snowball Earth period, early life not only survived but thrived, leading to the eventual emergence of complex multicellular organisms. The triggers for the Snowball Earth phenomenon included tectonic plate activity and volcanic outgassing, contributing to significant climate changes. These findings also provide insights into the Great Unconformity, suggesting it predates the Snowball Earth event, challenging previous theories about its formation. Researchers at the University of Texas have made a significant breakthrough in thermal interface materials, or TIMS, which could revolutionize cooling efficiency in data centers. This new TIM outperforms leading liquid metal solutions by an impressive 56 to 72%, making it a game changer in the field. The innovative material is a mechanochemically engineered blend of Sandstone, a liquid metal alloy, and ceramic aluminum nitride. This combination optimizes thermal performance through a unique colloidal process, allowing for remarkable heat dissipation capabilities. In lab tests, this TIM was able to dissipate up to 2,760 watts of heat from a 16 square centimeter area. This performance effectively bridges the gap between theoretical and practical heat transfer limits, which is crucial for modern technology. Data centers currently consume approximately 8 terawatt-hours annually on cooling, accounting for 40% of their total energy usage. The University of Texas researchers estimate that their TIM could reduce cooling energy needs by 13% across the industry, potentially lowering overall data center energy consumption by at least 5%. Gihua Yu, a professor at the Cockrell School of Engineering, emphasized the urgent need for efficient cooling solutions as power consumption in data centers continues to rise. This breakthrough could lead to substantial reductions in both operating costs and carbon emissions for data centers. Currently, the TIM is still in the research phase, with efforts underway to scale up production. The team is also preparing to collaborate with data center partners for further testing and practical applications. While the primary focus is on data centers, there are plans to make the TIM available for home PCs, potentially on platforms like Amazon or Newegg in the near future. The rising demand for data centers, driven by the growing popularity of AI, presents a vast market opportunity for high-performing TIMs like this one. In addition to improving cooling efficiency, the new TIM reduces the energy required for cooling systems by up to 65%, enabling denser configurations of heat-generating processors. For those interested in more detailed information about this TIM, a recent paper published in the journal Nature Nanotechnology provides further insights. A new study from NYU Langone Health has revealed a significant link between exercise and the risk of developing atrial fibrillation, or AFib. Participants who engaged in moderate to vigorous activities, like brisk walking or jogging, showed a remarkable 60% reduction in their risk of AFib when they averaged between 2.5 to 5 hours of physical activity weekly. The research, which analyzed data from over 6,000 Fitbit users, found that even adding just 1 more hour of exercise per week could decrease the risk of AFib by 11%. Dr. Sean P. Heffron emphasized that moderate activities, including walking, gardening, and dancing, can yield significant heart health benefits without requiring extreme exercise regimens. This study stands out for its long-term tracking of participants' physical activity over a year, making it the largest of its kind to explore the relationship between exercise and AFib. Unlike previous studies that relied on self-reported data, this research utilized fitness devices for precise data collection. Atrial fibrillation is a common irregular heartbeat that affects over 10 million adults in the U.S., potentially leading to serious health complications, including stroke and heart failure. Future research will delve into how the timing of exercise, such as morning versus evening workouts, may influence heart health, although the current study did not establish direct causation. This study is part of the All of Us research program by the National Institutes of Health, which aims to include diverse populations in medical studies, although the sample in this study was predominantly college-educated white women. To further reduce the risk of atrial fibrillation, individuals are encouraged to manage blood pressure and cholesterol, avoid tobacco, maintain a healthy diet, exercise regularly, ensure adequate sleep, manage weight, and reduce stress. The findings from this study will be presented at the American Heart Association's Scientific Sessions 2024, scheduled for November 16th to 18th in Chicago. Lead author Suptik Barua highlighted the importance of using Fitbits for providing objective data over extended periods, enhancing the reliability of the research. A recent study published in the Journal of the Endocrine Society indicates that vitamin D supplements may play a role in lowering blood pressure among older adults with obesity. The research involved 221 participants aged 65 and older, all classified as overweight and suffering from high blood pressure. Over the course of 1 year, participants received either 600 IU per day or 3,750 IU per day of vitamin D, along with 250 milligrams of calcium citrate. The results showed significant reductions in blood pressure for both groups. Participants in both dosage groups experienced an average decrease of 3.5 millimeters of mercury in systolic blood pressure and 2.8 millimeters of mercury in diastolic blood pressure, with those on higher doses showing a slightly greater reduction. The study confirmed that vitamin D supplementation can effectively lower blood pressure, but it also found that higher doses did not yield additional benefits. The research highlighted vitamin D's role in regulating the renin-angiotensin-aldosterone system, which is essential for blood pressure control. Despite these potential benefits, many individuals in the UK are not receiving adequate vitamin D due to poor dietary habits and lack of outdoor activity. According to the UK National Diet and Nutrition Survey, nearly a quarter of adults aged 19 to 64 and 1 in 5 adults over 65 have insufficient vitamin D levels. Experts recommend testing for vitamin D deficiency before beginning supplementation and advise following a doctor's guidance on appropriate dosage. However, excessive intake of vitamin D can lead to hypercalcemia, which may cause complications such as kidney stones and arterial deposits. Dr. Rita Hawley emphasized that vitamin D supplementation should be part of a broader health strategy that includes a balanced diet, regular exercise, and effective weight management. Overall, while the study supports the use of vitamin D for managing blood pressure, it stresses the importance of a holistic approach to health. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.